let's say that we have a bolt here, and we want to loosen this bolt with a wrench. And so what is the best way to loosen that bolt with a wrench? Well, we're going to apply a force. Well, where should we apply that force? Should we apply the force here at point A, or should we apply the force here at point B? Well, if I apply the same amount of force at A and B, it'll be easier to loosen that bolt if I apply it at B. And the reason being is because point B is further away from the axis of rotation, or the bolt itself. We call that distance the lever arm. And we abbreviate that with the letter D. We're going to use a D because it's a distance. And so even if I apply the same force, by applying it at point B, I will be able to loosen the bolt, whereas if I apply it at point A, I will not be able to loosen the bolt. So we're not talking about forces here. We're talking about something else. The ability to turn an object, the ability to rotate an object, is not force. It's not dependent on just force, because the same force, we can rotate it only if we apply it at point B. We're talking about a new topic, and that topic is torque. So torque is the ability to twist or turn something, which causes an object to have an angular acceleration. Forces cause objects to accelerate in a straight line. Torques cause objects to rotate, to spin faster or spin slower. So torques also cause an acceleration, but it's an angular acceleration. These things are vectors. We can apply torques to rotate it either clockwise or counterclockwise. Just like before, counterclockwise is positive, whereas clockwise is negative. The units of a torque is going to be a Newton meter. But you may know, if you work on cars at all, the English unit is a foot-pound. It is a force multiplied by a distance, because this rotation, this ability to rotate an object, again, depends not only on the force, but how far we are from the axis of rotation. So it's a Newton, force is measured in newtons, times a meter, because distance is measured in meters. So it's a Newton meter. We use Greek letters when dealing with rotation. So we're going to use the Greek letter for T, which is tau. Kind of looks like a fancy T with a hook on the bottom. And the equation, again, it depends on both force and distance. It is force times distance times the sine of the angle in between. So when dealing with the angle, what angle are we talking about? Well, if here's our situation, we have that wrench and we're applying a force. What angle are we referring to? Well, to figure out the angle, what you want to do is you want to use your pen, pencil, or finger and draw a straight line. Draw a straight line from the axis of rotation to the force, and then draw in the direction of that force. The angle that you have just made is going to be the angle that you use in your equation. Now, an angle of 90 degrees, according to our equation here, an angle of 90 degrees is going to produce a maximum torque for the minimum amount of force. So if you see the words maximum torque or minimum force, you know the angle is automatically 90 degrees. And the reason that is because our sine function is going to be, our sine of our angle can be anywhere between -1 and 1. If we look at a graph of that, sine of 0, 0, and the peak occurs when we're at 1, and the trough or valley occurs when we're at -1. And so the maximum occurs when we're at 90 degrees, and so a maximum torque happens at 90 degrees.